Okay, let's go through some ACT questions, and then I'm gonna go through the what you need to know for the test. So this first one, a formula to estimate the monthly payment is this, where A is the dollar amount, R is the annual interest rate expressed as a decimal, and Y is the years. And we want to know when A is multiplied by 2, what is the effect on P? Well, we can do two things here. So, I think the easiest way to do this is we have all these variables, let's just give them values. Because we want to know when we multiply it by 2 what the effect on P is. So that means we're just going to have to change the A variable and multiply by 2. Okay, so here, let's start this, by saying, okay, well, what if A equals 1, and let's let R equal 1, and let's let Y equal 1. Okay, so this will be P equals 1/2 times 1 times 1 times 1 plus 1 over 12 times 1. Which if we work this all out, we end up with 1.5 on top and 12 on the bottom, which if you simplify that will be 1/8. Okay, let's do the same thing now, but let's multiply A by 2. So then we're going to have A equals 2, R equals 1, and Y equals 1. So this is going to be P equals 1/2 times 2 times 1 times 1 plus 2 over 12 times 1, which 1/2 times 2 is 1, times 1 times 1 is 1. So we end up with a 3 on top, 12 on bottom, which is 1/4. So now we need to see what happened when we multiplied it by 2. So let's look at our two answers here. When we had it just as our normal ones, we got 1/8. And we had it multiplied by 2, we got 1/4. Well, we can rewrite 1/4 to have a common base as 1/8. This is the same as 2/8, which it makes it very clear to see, oh, we just multiplied by 2 there. Okay. Whoops. Okay, this one. So the points E and F lie on the standard coordinate plane. D lies between them. We want to know the length of EF. We want to know where D is. So D is somewhere between these, such that the length of EF, so this whole length, is 4 times the length of this right here. Okay. Well, let's do a couple things. So first, let's figure out what this length is. And I can use like Pythagorean theorem here, because we could just draw a right triangle. We can construct it. This length is 8. This length is also 8. So we could just go through and solve that. We'd have 8 squared plus 8 squared equals c squared. And I'm just going to use my calculator for this. So you get 128 equals c squared. So c equals the square root of that, which would be 11.3. Okay. Now we're looking for the length that is 1/4 of that. So if we test these points, so like let's test 7, 5. So say that this was possibly 7, 5. Well, that would mean that we'd have like 1 and 1 here, which 1 squared plus 1 squared is 2. So this would be c equals the square root of 2, which is 1.4, which 1.4 times 4 is definitely not 11.3. So let's try the next one. So 8, 6. So now let's say this is 8 comma 6. Well, if that's 8, 6, that means that this is 2, which this looks promising because 2 is a fourth of 8. Same thing here. So we'd have 2 squared plus 2 squared equals c squared, which that's 4 plus 4, that's 8, equals c squared. And then the square root of 8 would be 2.8. And if we multiply that by 4, you do get this. So that means our value there would be 8.6. Okay, so that's just kind of guess and check. Okay, this one. So given these two matrices, for some real number a, we want to know what x plus z are. So we need to figure out how to get x plus c. Well, this is really telling us, so this is what's happening here. So if we have a, 2, 6, 1, 4, this is the same as saying, well, 2a, 6a, 1a, 4a. And then the right side of this, that means that equals x, 27, y, and z. But there's two values here that are going to help us solve this. So we need to figure out what a is first. So we can look at those two. So from those two, we can see that, oh, okay, well, 6a equals 27. So if I divide this, not by a, by 6, I get a equals 27 over 6, which is also 9 halves, or 4.5. Okay, so I can just plug those in. So if I do 2, if I plug them in right here, 2 times 4.5 is 9. 6 times 4.5 we've already discovered is 27. 1 times 4.5 is 4.5. And 4 times 4.5 is 18. If I wanted to know what x plus z was, I could just do 9 plus 18, and you get 27. Okay, this last one, a container is 1/8 full of water. So we have this container, and this is 1/8 full of water right here. 10 cups are poured into here. And then the container now has 3/4 full of water. So this is now at 3/4, and this is our 10 cups right here. Okay, we want to know what is the volume of this container in cups. So we need to figure out how much this area is right here. Like how much in the container, like how much did the 10 cups fill when we were already full with 1/8 of it. So we could do 3/4 minus 1/8, and that will tell us what this is right here. Which that's going to be 6/8 minus 1/8 is 5/8. So that means 5/8 equals 10 cups. Whoops. Which tells me that 1/8 equals 2 cups. And there's 8/8 total. If each of those is 2 cups, we end up with 16 cups in there total. Okay. Okay, let's go over some things that I think you will want to know for the test. All your function operations. Whoops, what happened? Play from current slide. Okay, so you want to know all your function operations. So this is like the f plus g of x, f minus g of x, f times g of x, and f divided by g of x, and also f of g. And if you see like f of x, this is where you plug it in twice. So like this is the same as saying f of x. So So we plug this into the f of x first, and then whatever we get from here, we plug into this f of x. Okay. What else do we need? Average rate of change. Make sure you know how to do that. So a lot of like the last unit or the last section. Average rate of change, even and odd. So remember that even is symmetric with the origin. Odd is symmetric, or I said that wrong. Even is symmetric with the y-axis. Odd is symmetric with the origin. And to check this, this is where you plug in negative x. So if we plug in negative x and you get the same exact thing out, that's going to be an even function. If you plug in negative x and you get the exact opposite of your function, that is where it's odd. Okay, so be able to do that. More function operations. Finding zeros. So finding x-intercepts, zeros / x-intercepts. That's just where you solve the equation. So set y equal to 0 and solve. Increasing and decreasing. I want to talk about this. I'm going to do it in a different color. So increasing, this is one thing I see a lot. Increasing and decreasing. Make sure you are using the x values. X values, and it's always parentheses. So if you think about some function here, this would be increasing all from like here to here, right? And then it increases from here to here. But at this high point right here, it is not increasing or decreasing. Like think about if you are on a roller coaster and you get up to that top point, you are not increasing or decreasing at that point. You're waiting to see if you're going to keep going up or if you're going to start going down. So this point right here, you're not increasing or decreasing. Same thing here, which is why those have to be parentheses. Okay. Continuity, so like know where your jumps are and stuff. And then end behavior. Okay, please hop on the Google Meets if you have questions. I really miss you guys. I hope you're having a good day.